Right. Good evening, all of you. Good evening, Bhargav. Good evening, Chinna. Good evening, Sai Teja. Very good evening. Good evening, my dear students. Good evening, Lavanya. Good evening, Chaitanya. Join fast. Join fast. Inform to all of your friends. Like and share the session. Like this share cheyandi. Anybody can watch our videos. Join fast. My dear students, join fast. Like and share the session. Okay. Let me start with my introduction. Myself, Venkat Krishna. My qualification is MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience in GATE from training the students in 3 different subjects: design and analysis of algorithms, engineering mathematics, and discrete mathematics. Right. Welcome to Unacademy platform. Unacademy is the best online platform in India for all competitive examinations. When you go through Unacademy app, unacademy.com website, you can find many features. You can go through many live classes. So you have many lectures for GATE, ESE, JEE, NEET, for all competitive examinations. You can find a lot of lectures. Okay. So upcoming lectures will be posted and already classes completed classes will be posted there. So whole information will be with you. Whatever you want, you can have a lot of fun in that. Okay. Now let us see, in Unacademy there will be 2 types of subscriptions. One is Plus, another is Iconic. What is the advantage of Plus subscription? You will have 4 features. One is live classes, structured schedule, test series, and unlimited practice. Unlimited practice means daily DPP will be there. You know the meaning of DPP? Daily practicing problem. Every day faculty will give at least 5 to 10 questions. It gives a lot of practice to you. Okay. Now in case of Iconic, again you have 4 features. Personal coach. Let me start with personal coach. ప్రతి స్టూడెంట్ కి పర్సనల్ కోచ్ ని అపాయింట్ చేస్తారు. స్టడీ ప్లానర్ విల్ బి దేర్. మీకు ఎక్స్పర్ట్స్ నుంచి గైడ్ లైన్స్ వస్తాయి. ఏ సీక్వెన్స్ లో సబ్జెక్ట్ చదవాలి, ఎలా వెళ్ళాలి, ఎలా చదివితే మీకు టైం సేవ్ అవుతుంది. సో ప్లాన్ విల్ బి దేర్, ఎక్స్పర్ట్స్ గైడ్ లైన్స్, అండ్ యూ విల్ హ్యావ్ లాట్ ఆఫ్ క్వశ్చన్స్ అండ్ ఆన్సర్స్ ఆఫ్ ఇంజనీరింగ్ సర్వీస్ ఎగ్జామినేషన్స్. ఓకే, దీస్ ఆర్ ద ఫీచర్స్ ఇన్ ప్లస్ అండ్ ఐకానిక్. రైట్. సబ్స్క్రిప్షన్ తీసుకోవాలంటే వాట్ ఈస్ ద డ్యూరేషన్ టైం, వాట్ విల్ బి ద కాస్ట్? You will have 1 month subscription, 3 months, 6 months, 1 year, and 2 years. But we always suggest or advise students to take at least 1 year subscription. Why 1 year subscription? Because the fee cost is very affordable and whole syllabus will be covered within 1 year. You will have a lot of time to practice. You will have a lot of time to revise, and fee also very affordable. So it is 22,500 only. Okay. So let's talk about 1 year subscription. The actual fee is 25,000, but if you use my referral code GVK10, you will get 10% discount. So the final fee will be 22,500. I think this is clear. So if you want to take subscription in Unacademy Iconic for 1 year, the actual fee is 45,000. But when you use my referral code GVK10, you will get 10% discount. So the final fee will be 40,500. So these are various payment methods to take subscription either in Plus or Iconic. My dear students, remember this is my referral code GVK10. Hurry up, take subscription as early as possible, because within short span of time the fee structure in Unacademy is going to hike. Okay, really I am saying 22,500 is very affordable cost. 1 year subscription. You can listen to your favorite teacher any number of times. So whole knowledge will be shared, 100% guarantee. Okay. Right. Now in this session we discussed two problems, that is continuation of previous year questions on eigenvalues and eigenvectors. So we discussed in the last class, we have solved questions up to 126. Now let us solve two questions, 127 and 128, that is on spectral theorem and Cayley-Hamilton theorem. Okay, right. So we discussed two questions, continuation of previous class. In the last class, we had solved few problems based on Cayley-Hamilton theorem and spectral theorem. Now let us solve two questions. After that, we will discuss linear independence. Okay, linear independence, that means linearly dependent vector, linear combination, linearly independent vectors. And we are going to discuss one important concept, that is rank of a matrix in terms of linearly independent rows or columns of a matrix. Long back we had a discussion about rank of a matrix, that is based on determinant of original matrix, submatrices of size n-1 cross n-1, n-2 cross n-2, like this. Now today, once I finish few important definitions, I am going to discuss rank of a matrix, that is both square matrix as well as rectangular matrix in terms of linearly independent rows or columns. This is very, very important. Okay. After that, we will discuss norm of an eigenvector, normalized eigenvector. Okay. And then we will see how eigenvalues of an orthogonal matrix look like. What is the relation between eigenvalues of A and eigenvalues of A transpose? Okay. And then we discuss the number of scalar multiplications required to compute A dot B. It means that the number of scalar multiplications required to compute multiplication of two matrices. Okay, right. Let's see. Pratisha, good evening. Shivkumar, very good evening. Kavita, very good evening. Adarsh, good evening. Hari Krishna, good evening. Mahesh Babu, good evening. Mahendra, good evening. Right. Let us start with this 127 question. So this was given to electrical students in the year 2007. Here A is given as a 2 by 2 matrix and they were asking A power 9. They were asking A power 9. So what theorem you are going to apply, or you are supposed to apply Cayley-Hamilton theorem. Simple trick. When you have a problem, you should get immediate idea what theorem or what technique is to be applied on this problem. So you should have a lot of practice. So integral power of A, you can go for Cayley-Hamilton theorem or spectral theorem. Okay. So let us solve. If you want to solve it by Cayley-Hamilton theorem, what is the drawback in this case is it is a 2 by 2 matrix. So first you will get, when you apply characteristic equation, you will get A square. Okay. But I need A power 9. The power is slightly more. So after that, I can find A power 4. After that, I can find A power 8. At last, I will get A power 9. How to get A square? By using characteristic equation and application of Cayley-Hamilton theorem. In case of A power 4, I think the point is very clear, my dear students, because the size of this matrix is 2 by 2. When you go through its characteristic equation, it becomes a second degree polynomial expression. Am I right? Follow Gunara? In that case, you will get a second degree polynomial. So you can replace lambda by A. So you will get A square. You will get A square in terms of A. But we need A power 9. So once you get A square, you can find A power 4 by doing A square into A square. Once you get A power 4, A power 8 should be A power 4 dot A power 4. And then finally I need A power 9. So you can go A power 8 or A power 8 into A. Both are same. In both the ways, you can get the same result. So it means that three times you need to apply what is A square. So instead of that, we can go for spectral theorem. You will get the answer within 1 or 1.5 minutes. Let's see. So here, sum of elements of R1 is -1. Sum of elements of R2 is -1. The sum is common number. So one of its eigenvalue is -1. Second eigenvalue, the trace of this matrix is minus 3. Already here minus 1 is covered. So next eigenvalue should be minus 2. Got it? Now these are eigenvalues of A. So here I am writing eigenvalues of A are minus 1 comma minus 2. But they asked A power 9. So I will try to find eigenvalues of A power 9 by using simple shortcut. They are minus 1 whole power 9 comma minus 2 whole power 9. So they are nothing but minus 1 comma minus 5 1 2. Minus 1 comma minus 1 2. I think this point is clear. Now I am going to verify options. If only one option has eigenvalues minus 1 minus 5 12, it means that that has to be A power 9. You may have some doubts. Sorry, if two different options have eigenvalues minus 1 and minus 5 12, then which has to be taken as A power 9? Then in that case, you must solve it by Cayley-Hamilton theorem only. You do not have any alternative in that case. I think that point is clear. So look at option A. So replace A by first eigenvalue. So 512 into minus 1. So this is a minus 511 plus 510 into 1 because eigenvalue of I is 1. So it becomes minus 1. So its eigenvalue is matching with A power 9. Match కాకపోతే నేను eliminate చేయొచ్చు. ఒక eigenvalue match అయింది. So let's proceed to evaluation of second eigenvalue. So 512 into A plus second eigenvalue రాయండి minus 2. 511 into minus 12. Minus 2. 511 into minus 2. So you will get minus 1022 plus 510. This is minus 512. So therefore option A eigenvalues are matching with A power 9. But can I confirm that A is right answer? No. Two different matrices can have same eigenvalues. But if two matrices will have at least one difference in eigenvalue, one difference point, not one difference, one difference point in terms of eigenvalue, I can say that they are different matrices. So therefore, I am not confirming A, I am not eliminating A. Got the point? So hold it, hold up at end. Next option B grandi. A plus no first eigenvalue minus 1 randi. So minus 309 plus 104. So this is nothing but I think minus 205. So this is not at all an eigenvalue of A power 9. So there is a mismatch. So eliminate this. Mismatch అయితే eliminate చేయొచ్చు. Second eigenvalue కూడా find out చేయాల్సిన అవసరం లేదు. Come to option C. 154 into minus 1. Minus 154 plus 155. So it is 1. 1 is not matching with eigenvalue of A power 9. So eliminate C. Come to option D. One of its eigenvalue is E power minus 9. But this is not matching with minus 1 as well as minus 2. So therefore D also eliminated. Hence option A is right answer. Got my point, students? Any doubt? Right, Bhavani, you are right. You are right. Hi Ramesh, PV. Hi Bhavani. Yes, you are right. Minus 1, minus 5, 12 are eigenvalues of A power 9. And those eigenvalues are matching with only option A. Hence, option A is right answer. Option A is right answer. I think this point is clear. Got it? Very nice. Very good. Very nice. Right. Next question, 128. This one and previous year, previous question, both are linked questions. Okay. Same matrix. Then they asked, then A satisfies the relation. So here you can see the highest power of A is 2. Here the highest power of A is 2. Here the highest power of A is 2. So simple application. Apply Cayley-Hamilton theorem. You will get the result within 30 seconds. Its eigenvalues are minus 1 comma minus 2. So what is my characteristic equation? Lambda plus 1 times lambda plus 2 equal to 0. Let me simplify this. you will get a lambda square plus 3 lambda plus 2 equal to 0. So this is characteristic equation of this matrix A. Now here at this moment, I am going to apply CH theorem. CH means Cayley-Hamilton theorem. So lambda should be replaced by A. A square plus 3A plus last constant should be replaced by constant into I, and this 0 should be replaced by null matrix. So A square plus 3A plus 2I equal to 0. A square plus 3A plus 2I equal to 0. Now let us see. Option A is wrong answer. So here it is 2A. This is wrong answer. This is wrong answer. So when you simplify this by normal multiplication, I think option C becomes A square plus 3A plus 2I equal to 0. So C is my right answer. So option C is right answer. I think the point is very clear. Very nice. Very nice, Adarsh. Very nice, Saiteja. Very good response. C is right answer. Right. Now we discuss theoretical part. We start with the definition of linear combination. Let us see what is a linear combination. Let us start with some n cross n matrix A. Let us start with some n cross n matrix A. So it will have n rows and n columns. I can go for terminology of vector. Each row can be called as vector of a matrix. Each column can be called as a vector of a matrix. So I am going to define, let A be any n cross n matrix with vectors. Here vectors means they can be either rows or columns. They can be either rows or columns. So let A be any n cross n matrix with n vectors, with vectors. So here it is n. Say alpha 1, alpha 2, alpha 3 and so on, comma alpha n. Now I want to define linear combination of these vectors. Then A1 dot alpha 1 plus A2 dot alpha 2 plus A3 dot alpha 3 and so on plus AN dot alpha n is called a linear combination of alpha 1, alpha 2 and so on alpha n. Students, remember one point, linear means the power should be either 0 or 1. The power should be either 0 or 1. మీరు A1 తీసుకుంటే A1 పవర్ 0 అయినా ఉండాలి, 1 అయినా ఉండాలి. Alpha 1 పవర్ 0 అయినా ఉండాలి, 1 అయినా ఉండాలి. So always remember that linear means power should be either 0 or 1. Linear means power should be either 0 or 1. So therefore A1 dot alpha 1 plus A2 dot alpha 2 and so on plus AN dot alpha n is called linear combination of alpha 1, alpha 2 and so on alpha n. You may ask me what is A1, A2 and so on AN. They are nothing but constants. Now in this terminology, as I have used vectors, I am going to have some new terminology for constants. They are nothing but scalars. So therefore in this case where A1, A2, A3 and so on AN are any constants. You can have 0, You can have positive constants. Few constants can be 0, few can be positive, few can be negative. Even fractional values are also allowed. So here constants can also be called as, in this called scalars. Constants is also called as scalars. I think the definition is very clear. Okay, the definition is very clear. Right. Let us take an example. Suppose let us take A equal to 1, 2, 3, 4, 2 by 2 matrix. Here alpha 1 I will take as first row. You can take it as an ordered pair 1, 2. Alpha 2 second row, that is 3, 4. So now you can have 2 alpha 1 మీస్ట్ వచ్చిన కాన్స్టెంట్ తీసుకోండి. ఆల్ఫా 1 ని మీస్ట్ వచ్చిన నెంబర్ తో మల్టిప్లై చేయండి. ప్లస్ 5 into alpha 2. Alpha 2 ని 5 తో మల్టిప్లై చేస్తున్నాను. So therefore this is 2 into 1, 2 plus 5 into 3, 4. So this is, you can go for normal multiplication. 2 plus 15, 17, 4 plus 20, this is 24. So the result is also a vector. You can call it as alpha 3. Some vector, some general vector that need not be part of the vector. So you can multiply alpha with in any vector. You can multiply alpha 2 with any scalar. So a1, a2, a3 and so on, and they can be any constants. All can be 0, all can be positive, all can be negative. Few can be positive, few can be negative, few can be 0. There is no restriction on this. Okay. So restriction eppudu vastundo chuddamandi. We will discuss shortly. I think this point is very clear. So what is my conclusion is a linear combination of n number of vectors is also a vector. తీసుకుంటే అన్ని కాలమ్స్ తీసుకోండి, లేకపోతే అన్ని రోస్ తీసుకోండి. I think the point is very clear, right? Is this clear? Right. Let me go through chart. Praveen Kumar sir, when differential equation starts, it takes more than 1 week. Next, Vijay Kishan sir, how to calculate number of independent solutions? ఇంకా టైం ఉందండి. లీనియర్లీ ఇండిపెండెంట్, లీనియర్లీ డిపెండెంట్ కి వెళ్ళలేదు. సో ఇంకా డెఫినేషన్ స్టార్ట్ చేయలేదు. విజయ్ కిషన్, వెయిట్ ఫర్ సమ్ టైమ్. ఓకే. నెక్స్ట్ లాస్ట్ స్టెప్, హౌ సార్? వెరీ సింపుల్. నార్మల్ ఇవాళ మల్టిప్లికేషన్ అండి. 2 into 1 2 కదా, 5 into 3 15 plus 2 17, 2 into 2 4, 4 plus 5 into 4 20, 4 plus 20 24. That's it. Normal multiplication and normal addition. కరస్పాండింగ్ పొజిషన్ లో ఉన్న ఎలిమెంట్స్ ని మల్టిప్లై చేసి అవి యాడ్ చేయండి, అంతే. దట్ ఈస్ వెరీ క్లియర్. ఓకే, రైట్. ఐ థింక్ దిస్ డెఫినేషన్ ఈస్ వెరీ క్లియర్ టు ఆల్ ఆఫ్ యూ. వెరీ సింపుల్ డెఫినేషన్, నథింగ్ గ్రేట్ ఇన్ దిస్. ఓకే, next we discuss linearly independent vectors. Very, very important definition. Very, very important. Students, try to focus more on this lecture. Linearly independent vectors. Chinna, you are asking 2 and 5, any numbers. Any numbers you can take. Linear combination definition వరకు మీరు a1, a2, a3 and so on, an ఏ కాన్స్టెంట్స్ అయినా తీసుకోవచ్చు. నో రెస్ట్రిక్షన్, నో రెస్ట్రిక్షన్. లీనియర్లీ ఇండిపెండెంట్, లీనియర్లీ డిపెండెంట్ వెక్టర్స్ లో మాత్రం రెస్ట్రిక్షన్ వస్తుంది. ఆ రెస్ట్రిక్షన్ బేస్ చేసుకొని we are going to say that these vectors are linearly independent and these vectors are linearly dependent. Okay, right. Let A be any n cross n matrix with vectors. Vectors means rows or columns. Alpha 1, alpha 2 and so on, alpha n. Now let us see when we say that these are Li. We say that alpha 1 comma alpha 2 and so on alpha n, or Li. Li stands for linearly independent. Li if a1 dot alpha 1 plus a2 dot alpha 2 plus a3 dot alpha 3 and so on an dot alpha n equal to 0 bar. Here 0 bar means 0 vector. It means that all elements of this row or this column are 0. All elements of this row or column are 0. ప్రతిసారి మనం రోస్ కి ఇంపార్టెన్స్ ఇద్దాం. ఓకే, కాలమ్స్ అయినా తీసుకోవచ్చు, అన్ని తీసుకుంటే అన్ని కాలమ్స్ అయినా తీసుకోండి, లేదా అన్ని రోస్ అయినా తీసుకోండి. But generally we have a practice of taking all rows at a time. So we say that these vectors are Li. If linear combination is 0, implies each scalar must be 0. A1 equal to 0, A2 equal to 0, A3 equal to 0 and so on, An equal to 0. There is a difference between 0 and 0 bar. E0 ki difference kosam akkada bar rasanu. Vector, it means it is a row or column where all elements are equal to 0. What does it mean is, that is linear combination becomes 0. Linear combination becomes null vector. That is best terminology, null vector. If I say 0, you may confuse whether it is vector or scalar. Linear combination becomes null vector only when all scalars are zero. The point is clear. Okay, right. Linear combination becomes null vector only when all scalars are 0. I think the point is very clear. Bhargav, what's your question? Sir, differential equations Unacademy special classes lo చెప్తున్నారు కదా, మళ్ళీ తెలుగులో చెప్తారా? Let's see. Wait and see. I will give. So ముందు ఇప్పుడు సబ్జెక్ట్ లో డౌట్స్ అడగండి. Okay, don't worry Bhargav. Points will be covered, very thing. Okay, you need not worry about those points. One important announcement to all of you is, as Bhargav asked one question, one important announcement to all of you is, tomorrow as usual we have a class from 7 to 8:15 p.m. Today we have class 7:15 to 8:15. And from tomorrow onwards, we have a class from 7 p.m. to 8 p.m. only. And for foundation course, from tomorrow, the class will be from 8:30 to 9 p.m. Half an hour. Don't worry, all points will be covered. All points will be covered. So don't think about why we are reducing time, all these things. Okay. So from tomorrow, and we don't have a YouTube class on Saturday. We don't have any class, mathematics class, particularly mathematics. I don't know about rest of the things. I'm talking about my classes. So we do not have this Saturday a YouTube class. Saturday, Sunday, I'm going to take special classes in Unacademy. Okay. Saturday, Sunday, I'm going to take special classes in Unacademy. అవి 3 ఉంటాయా 2 ఉంటాయా అనేది, that depends upon busyness of my schedule, etc. But definitely you can expect at least 4 minimum 4 to maximum 6. 4 to 6 you can expect on weekends. Don't worry. Okay. So tomorrow, day after tomorrow, that is Monday, Tuesday, Wednesday, Thursday, Friday. This week, Tuesday, Wednesday, Thursday, Friday, 7 to 8 p.m. class, and foundation course will be 8:30 to 9 p.m. Okay. And 4-year series will be discussed in the next week. Areas of course will be discussed. I don't leave any point. All points will be covered. I know most of the people are appearing GATE 2021. So I have all the things in my mind. You need not worry. Okay. Right. Jaytarak sir, Hermitian and skew Hermitian matrices kuda cheppandi. Sir, anni cheptam sir. మీరు సబ్జెక్ట్ ఇది చెప్పనివ్వకుండా అవి చెప్పండి ఇవి చెప్పండి అని అడుగుతున్నారు. ప్రతిదీ చెప్తానండి. Who will see? I took almost, this was 17th lecture. Very first lecture was over your syllabus. That forget about it. In the second lecture on September 17th, I have started linear algebra. So this was officially 16th class linear algebra. So almost this was a 20th hour. If I complete today's class, 20 hours, 20 into 60 minutes. Who will take 20 hours? I'm spending a lot of time. I'm telling you clear notes. I'm telling you clear notes. I will discuss all points. You don't worry. You don't worry. I will continue full class. All points will be covered. ఒక్కోసారి మీరు ఎక్స్పెక్ట్ చేసిన రేపు రావచ్చు, ఒక రోజు ముందు రోజు రావచ్చు. We have some plan of sequence. Okay. We have some plan of sequence and we have many other works also. So we know at what time, if we discuss, all students can understand all points. Tomorrow I'm going to discuss complex matrices. Okay. So do you want any schedule? ముందే షెడ్యూల్ చెప్పేసామనుకోండి, ఇన్ కేసు ఏదైనా ప్రాబ్లమ్స్ డిలే అయితే ఇవాళ మేము అది అనుకొని వచ్చాము అంటుంటారు. ఓకే, సో విల్ బి డిస్కస్డ్. డోంట్ వరీ, డోంట్ థింక్ దట్ ఇవి చెప్తారా ఇవి చెప్పరా ఇవన్నీ మీరు ఏమనుకోవద్దు. వెక్టర్ స్పేస్ కూడా చెప్తాం, తెలుసా అండి మీకు? వెక్టర్ స్పేస్ డైమెన్షన్ దట్ వాజ్ ఇంక్లూడెడ్ ఇన్ ద సిలబస్. వెరీ స్టార్టింగ్ క్లాస్ లో ఓవర్ యువర్ సిలబస్ లో నన్ను అడిగారు స్టూడెంట్స్, వెక్టర్ స్పేస్ ఉందా సార్ సిలబస్ లో అనేసి. ఎస్, ఇట్ ఈస్ దేర్. వెక్టర్ స్పేస్ ఉంది. వెక్టర్ స్పేసెస్ కూడా చెప్తాను. ఏది వదిలిపెట్టే సమస్య లేదండి. మీరు ఎక్స్పెక్ట్ చేయని టాపిక్స్ కూడా వస్తాయి. నేను క్లాస్ లో డిస్కస్ చేస్తున్న ప్రాబ్లమ్స్ చూసి మీకు క్లారిటీ రావాలి కదా. నేను క్లాస్ లో చెప్తున్న ప్రాబ్లమ్స్ లో యూజీసీ క్వశ్చన్స్, హెచ్సియూ క్వశ్చన్స్, ఎంఏ బ్రాంచ్, ఇంజనీరింగ్ సైన్స్, మీరు ఎలక్ట్రికల్, ఈసీఈ, ఇన్ కేసు మెకానికల్, సివిల్ జాయిన్ అవ్వచ్చు అప్పుడప్పుడు కొంతమంది. ఈ 4 బ్రాంచెస్ ప్రాబ్లమ్స్ తో కంటే ఇంకా డిఫరెంట్ క్వశ్చన్స్ ఎక్కువ వర్కౌట్ చేస్తున్నాం మనం. సో ప్రాబ్లమ్స్ కూడా వర్కౌట్ చేస్తాం, దాని కరెస్పాండింగ్ థియరీ కూడా ఎక్స్ప్లెయిన్ చేస్తాం కదా వెరీ క్లియర్ గా. సో మీరు ఇక్కడ చార్ట్ లో ఇవన్నీ చెప్తుంటారు కదా, సార్ ఇవన్నీ చెప్పండి ఇవన్నీ అనేసి, ఇవి చెప్పండి ఈ పాయింట్స్ ఇవన్నీ చెప్పండి అని అంటున్నారు కదా. నేను ప్రతిసారి మిమ్మల్ని చార్ట్ చేస్తున్నాను అనుకోండి, దిస్ క్లాస్ ఫ్లో అనేది మిస్ అవుతూ ఉంటుంది. ఐ విల్ డిస్కస్ డెఫినెట్లీ ఆల్ పాయింట్స్. ఐ విల్ క్లారిఫై యువర్ డౌట్స్ ఆల్సో. ఓకే, 100% no doubt about that. Okay. Now let us come to this. So in this case, linear combination becomes null vector only when all scalars are 0. So do you have any example? Look at this. మీరు ఎప్పుడైనా సరే ఎగ్జాంపుల్ అడిగారు అనుకోండి ఎవరైనా సరే, I will tell you like this. Please look at this. Suppose 1 2 2 4 తీసుకోండి. Look at, take simple example. For rough point of view, I am using left points. Don't worry. So 1 2 2 4. Here alpha 1 is nothing but 1 comma 2. Alpha 2 is nothing but 2 comma 4. We have a close relation here. Alpha 2 is nothing but 2 into alpha 1. It means that alpha 2 is linearly depending on alpha 1. It means that alpha 1 and alpha 2 are linearly dependent vectors. Okay, you got some clarification. ఇక్కడ ఒక ఎగ్జాంపుల్ ఇస్తాను చూడండి. 2 examples I will give, don't worry here. Suppose you take A equal to 1 2 4 7. Here alpha 1 equal to 1 comma 2. Alpha 2 equal to 4 comma 7. ఆల్ఫా 1 ని ఏదైనా నంబర్ తో మల్టిప్లై చేస్తే ఆల్ఫా 2 వస్తుందా? సడన్లీ నాట్. ఇక్కడ మీకు 1 ఉందండి, ఇక్కడ మీకు 4 ఉంది. సో ఆల్ఫా 1 ని 4 తో మల్టిప్లై చేస్తే ఆల్ఫా 2 వస్తుందని మీకు డౌట్ రావచ్చు. ఇక్కడ 4 వస్తుంది, కానీ ఇక్కడ 4 into 2 8 రావాలి, కానీ ఇక్కడ 7 ఉంది. సో ఆల్ఫా 2 ఈజ్ నాట్ ఏ మల్టిపుల్ ఆఫ్ ఆల్ఫా 1. ఇట్ మీన్స్ దట్ ఆల్ఫా 2 ఈజ్ నాట్ ఏ మల్టిపుల్ ఆఫ్ ఆల్ఫా 1. K is any constant. Similarly, alpha 1 is not a multiple of K into alpha 1 is not a multiple of alpha 2 for any constant K. So here K is any constant. అంటే ఏ నంబర్ తో మల్టిప్లై చేసినా ఆల్ఫా 1 ని ఏ నంబర్ తో మల్టిప్లై చేసినా ఆల్ఫా 2 రాదు. ఆల్ఫా 2 ని ఏ నంబర్ తో మల్టిప్లై చేసినా ఆల్ఫా 1 రాదు. ఇట్ మీన్స్ దట్ దే ఆర్ లీనియర్లీ ఇండిపెండెంట్. సార్ ఇది 2x2 మ్యాట్రిక్స్ కాబట్టి మనం ఈజీగా చెప్పాము, మరి అక్కడ డెఫినేషన్ చాలా కాంప్లికేటెడ్ గా ఉంది. Definition is not complicated. You may be looking at this example, this definition very first time, so you may feel that this is difficult, but let me make this very simple in the second example. Okay. Let us take second one. Suppose I am taking A equal to 1 0 0 0 1 0 0 0 1. This is identity matrix. So here I want to say that all the rows of this matrix are linearly independent. Now what is alpha 1? First row. 1 0 0 alpha 2 0 1 0 alpha 3 0 0 1. ఇవి linearly independent అని prove చేయాలి. So if you want to prove that vectors are linearly independent, take its linear combination equal to 0. Let a1 dot alpha 1 plus a2 dot alpha 2 plus a3 dot alpha 3 equal to null vector. So you are going to prove that a1 is 0, a2 is 0, a3 is 0. So a1 into 1 0 0 plus a2 into 0 1 0 plus a3 into 0 0 1. 0 vector means 0 0 0. So here you can go for left side simplification. Anni simplify chesi add cheyandi. You will get ordered triple a1, a2, a3 equal to 0 0 0. Therefore my conclusion is a1 is 0, a2 is 0, a3 is 0. It means that whenever linear combination is 0 bar, it means that all constants are becoming 0. Therefore, my conclusion is alpha 1, alpha 2, alpha 3 are linearly independent. Any doubt? Any doubt in this? సో మీకు ఎప్పుడైనా సరే లీనియర్లీ ఇండిపెండెంట్ ప్రూవ్ చేయాలంటే ఒక 3 వెక్టర్స్ ఇచ్చి 4 ఇచ్చిన 3 వెక్టర్స్ ఇచ్చి లీనియర్ ఇండిపెండెంటా కాదని వెరిఫై చేయాలంటే టేక్ లీనియర్ కాంబినేషన్ ఈక్వల్ టు 0 బార్. అంటే లీనియర్ కాంబినేషన్ 0 బార్ అవ్వాలంటే ఖచ్చితంగా a1 0, a2 0, a3 0 వేరే ఆల్టర్నేటివ్ లేదు సార్ అని మీకు అనిపిస్తే you can confirm that alpha 1, alpha 2, alpha 3 are linearly independent. Okay. Alpha 1, alpha 2, alpha 3 are linearly independent. Linearly dependent vectors ki leka meeku clarity vastundi. No problem. Just wait for few minutes. You will get more clearance. Next, I will go for linear dependent vectors. Linear dependent vectors. Let A be any n cross n matrix with n vectors, say alpha 1, alpha 2, alpha 3 and so on alpha n. We say that these vectors are LD linearly dependent if there exist scalars a1, a2 and so on an such that at least a constant 1 ai not equal to 0. If there exist scalars a1, a2, an, you can go like this. With at least 1 a not equal to 0 such that a1 dot alpha 1 plus a2 dot alpha 2 plus a3 dot alpha 3 and so on plus an dot alpha n equal to 0 bar. I think this definition is very clear. Okay. That is linear combination can be 0, can be null vector linear combination can be null vector for at least one non-zero scalar. For at least one non-zero scalar. Right. లీనియర్లీ ఇండిపెండెంట్ కి లీనియర్లీ డిపెండెంట్ కి డిఫరెన్స్ ఏంటి? క్వైట్ ఆపోజిట్. మీకు లీనియర్లీ డిపెండెంట్ వెక్టర్స్ కైనా లీనియర్లీ ఇండిపెండెంట్ వెక్టర్స్ కైనా వీ హ్యావ్ ఏ సింగిల్ టాస్క్, దట్ ఈస్ లీనియర్ కాంబినేషన్ షుడ్ బి ఈక్వల్ టు నల్ వెక్టర్. ఆల్ ఆఫ్ యూ అటెన్షన్ ప్లీజ్. మీకు లీనియర్లీ డిపెండెంట్ వెక్టర్స్ అయినా లీనియర్లీ ఇండిపెండెంట్ వెక్టర్స్ కైనా సరే మన అల్టిమేట్ గోల్ ఏంటి? లీనియర్ కాంబినేషన్ ఆఫ్ దోస్ వెక్టర్స్ షుడ్ బి జీరో. వెరీ సింపుల్ లాజిక్ అండి. మీకు ఎప్పుడైనా లీనియర్ కాంబినేషన్ జీరో బార్ రావాలి అని అంటే 3 వెక్టర్స్ తీసుకోండి, a1 a2 a3. what is my linear combination? a1 dot alpha 1 plus a2 dot alpha 2 plus a3 dot alpha 3. ఇది జీరో బార్ అవ్వాలి అని అంటే వితౌట్ గోయింగ్ ఫర్ ఎనీ కాన్స్టెంట్స్ anyone will have simple alternative, that is a1 equal to 0, a2 equal to 0, a3 equal to 0. so linear combination zero bar రావడానికి one of the simple effort from all of our side is taking all scalars equal to 0. అంటే అన్ని వెక్టర్స్ ని జీరోతో మల్టిప్లై చేస్తే డెఫినెట్ గా లీనియర్ కాంబినేషన్ జీరో బార్ వస్తుంది, రైట్? ఆ కాంబినేషన్ కాకుండా వేరే కాంబినేషన్ తో కూడా నల్ వెక్టర్ వస్తే దే ఆర్ కాల్డ్ లీనియర్లీ డిపెండెంట్. లేదు సార్ లీనియర్ కాంబినేషన్ జీరో బార్ రావాలంటే ఖచ్చితంగా కాన్స్టెంట్స్ అన్ని జీరోస్ తీసుకుంటేనే వస్తుంది అనుకుంటే దే ఆర్ లీనియర్లీ ఇండిపెండెంట్. హోప్ మై పాయింట్ ఈస్ వెరీ క్లియర్. మై పాయింట్ ఈస్ వెరీ వెరీ క్లియర్. అండర్స్టాండ్? ఈజ్ మై పాయింట్ క్లియర్? సో లీనియర్ కాంబినేషన్ జీరో బార్ రావాలని అంటే అన్ని కాన్స్టెంట్స్ జీరో తీసుకుంటేనే లీనియర్ కాంబినేషన్ జీరో బార్ వస్తే దోస్ వెక్టర్స్ ఆర్ లీనియర్లీ ఇండిపెండెంట్. సార్ అటువంటి సిచ్యువేషన్ కాకుండా నాన్ జీరో స్కేలార్స్ తో కూడా లీనియర్ కాంబినేషన్ జీరో బార్ వస్తుందని మీరు ప్రూవ్ చేయగలిగితే దే ఆర్ లీనియర్లీ డిపెండెంట్. వెరీ సింపుల్ అండి. డౌట్ ఐ విల్ టేక్ అన్ ఎగ్జాంపుల్. Let us take examples. First one, take a equal to 1 2 3. This one is 1 2 3 6. Here alpha 1 is 1 comma 2, alpha 2 is 3 comma 6. Here you can see alpha 2 is 3 times of alpha 1. So I can say that 3 alpha 1 plus minus 1 into alpha 2. Null vector hai kada. So this is a1 and this is a2. ఇక్కడ a1 plus 3 plus లో మీరు 0 రాసిన minus 1 plus లో 0 రాసిన లీనియర్ కాంబినేషన్ 0 బార్ వస్తుంది. బట్ దట్ ఈస్ నాట్ ద ఓన్లీ కాంబినేషన్ వేర్ లీనియర్ కాంబినేషన్ బికమ్ 0. ఇక్కడ నాన్ జీరో కాన్స్టెంట్ మీకు కనిపిస్తున్నాయి. So therefore here alpha 1 comma alpha 2 are linearly dependent. Got this point? Alpha 1, alpha 2 are linearly dependent. I will go to one more example. Don't worry. Many examples I will provide. So suppose a equal to 2 minus 1 4 0 0 1. Say for example this is minus 4 2 minus 8. So in this case alpha 1 equal to 2 minus 1 4, alpha 2 equal to 0 0 1, alpha 3 equal to minus 4 plus 2 minus 8. Now you can have the relation between alpha 1 alpha 3. Here alpha 3 equal to, in the second example, alpha 3 equal to minus 2 into alpha 1. But alpha 2 include avaledu kada. You need not worry. I can have like this, minus 2 into alpha 1 plus 0 into alpha 2. This one is, you can take this one as to the right side or right side. So I can go like this. Then you can have like this. So this is 2 alpha 1 plus 0 into alpha 2 plus 1 into alpha 3. ఇది మొత్తం null vector వస్తుంది. Now you can have a glance about this. This is a1, this is a2, this is a3. కనీసం ఒక కాన్స్టెంట్ ఏదో నాన్ జీరో ఉంది కదా. So linear combination is becoming zero for at least one non-zero constant. So therefore in this case alpha 1, alpha 2, alpha 3. They are linearly dependent. Hope this point is clear. This point is very, very clear. No doubts at all. Okay. Any doubt, my dear students? So I worked out two examples in case of linear dependent vectors. First example is very clear. 1, 2, 3, 6. Here we have a close relation. Alpha 2 equal to 3 alpha 1. So you will get this. 3 alpha 1 minus 1 into alpha 2 equal to 0 bar. Here 3 is A1 minus 1 is A2. So linear combination is becoming 0 bar for some non-zero constants. So they are LD. But in the case of second example, there is a close relation between alpha 1 and alpha 3. Alpha 1 and alpha 3. You need not worry about alpha 2. So I can have this equation. Alpha 3 equal to minus 2 into alpha 1. So you can establish this equation. It means that my linear combination is becoming 0 for at least one non-zero constant. You deeply observe definition, you can understand. So linearly independent ante anni scalars zeros avali. Linearly dependent ante anni scalars non-zero అని కాదు. At least one constant should be not equal to 0. That point, now the point is very, very clear. You don't have any doubts. It is very clear, crystal clear. Thus we define linearly independent set. Next one is linearly independent set. Very simple definition. A set having linearly independent vectors is called linearly independent set. So here I am writing this. A set having linearly independent vectors is called a Li set. Next, I will define linearly dependent set. Dependent. Previously independent, now it is dependent. Linearly dependent set. Very simple definition. A set having linearly dependent vectors a set having linearly dependent vectors is called a LD set. Is called a LD set. Definition is clear, right? Now let me ask you one simple question. Suppose I have a matrix. Forget about its size. I think the terminology of vector and scalar is very clear. Vector means it can be row or column. Scalar means it's a constant. You take any n cross n matrix. Suppose one row is completely filled with 0. That is called null vector. So do you say that a 0 vector is a LD or Li? Question is clear. A single 0 vector, is it Li or LD? Single 0 vector. Suppose I have an example like this. Alpha equal to 0, 0, 0. It is single 0 vector, null vector. Now my point is it Li or LD? Is it Li or LD? Any answers? Kavita, you are asking one doubt. How you wrote the last equation, sir? Alpha 3 equal to minus 2 alpha 1 కదా ఇక్కడ. ఈ మైనస్ 2 ఆల్ఫా 1 లెఫ్ట్ సైడ్ తీసుకెళ్ళండి. సో అప్పుడు 2 ఆల్ఫా 1 వస్తుంది. అప్పుడు రైట్ సైడ్ నల్ వెక్టర్ ఉన్నట్లే కదా. ప్లస్ ఆల్ఫా 3 అలాగే రాయండి. ఆల్ఫా 2 కూడా ఇంక్లూడ్ చేయాలి కాబట్టి దాన్ని 0 to మల్టిప్లై చేసేయండి. ఈ రెండు ఎలాగో యాడ్ చేస్తే 0 వస్తుంది. ఇది ఎలాగో 0. లైక్ దిస్. గాట్ ఇట్? రైట్. Now I am going to write about null vector. Single null vector, is it Li or LD? Simple logic and 2 into alpha 0 nega null vector. So this is in the form a1 dot alpha 1 equal to null vector, but still it is a non-zero constant. So a single zero vector is always LD. So my note is very, very useful note. These points are very, very useful in defining the rank of a matrix. Any single zero vector is always LD. Simple thing, take alpha equal to 0, 0, 0. Here you can write 2 into alpha equal to 0. This is a dot alpha equal to 0. But here a value is not equal to 0. So linear combination is becoming 0 for at least one non-zero constant. Therefore, a single zero vector is always LD. Next, one more note. What about non-zero vector? Suppose I have alpha equal to like this 2, 1, 0. This is non-zero vector. Zero vector ante anni elements zeros undali. Non-zero vector ante at least one element non-zero unte chalu. Antegani anni elements non-zero ani kaadu. So 2, 1, 0. Is it Li or LD? A single non-zero vector. A single non-zero vector, is it linearly independent or linearly dependent? Try to answer my question. A single non-zero vector, is it Li or LD? Vijay Kishan, you are right. ఇక్కడ మీకు 2, 1, 0 కనిపిస్తుంది కదండి, సింపుల్ అండి. సపోజ్ నేను ఆల్ఫా ఈక్వల్ టు 2, 1, 0 తీసుకున్నాను. ఇది నాన్ జీరో వెక్టర్. Li అని ప్రూవ్ చేయాలంటే మీరు ఫస్ట్ లీనియర్ కాంబినేషన్ 0 వరకు ఈక్వల్ చేయండి. అప్పుడు సింప్లిఫై చేయండి, ఏ వాల్యూ 0 వస్తుంది. యూ కెన్ వెరిఫై. సో హియర్ మై కంక్లూజన్ ఈస్ ఎనీ సింగిల్ నాన్ జీరో వెక్టర్ is always Li. I think the point is very, very clear. Right. Do you have any doubts up to this moment? I think it is very clear to all of you. If you have any queries, feel very free to ask me, because I am going to define rank of a matrix in terms of linearly independent rows or columns of a matrix. Now I am going to discuss rank of a matrix in terms of linearly independent rows or columns. In terms of linearly independent rows or columns of a matrix. Right. Shall we start with an example instead of going for definition directly? That is best. So I will go through an example at first. So let us have two examples. Suppose I have A equal to 1, 2, 3, 4. Here alpha 1 is 1, 2. Alpha 2 equal to 3, 4. With a normal experience, with the previous classes experience, could you say what is rank of A? What is rank of this matrix? A equal to 1, 2, 3, 4. A equal to 1, 2, 3, 4. What is the rank of this matrix? For a 2 by 2 matrix, maximum rank will be 2. Otherwise, it can be 1. Otherwise, it has to be 0. So 2, 1, 0. These will be the possible ranks of a general 2 by 2 matrix. So you come from top to bottom. So its det value is not equal to 0. Its rank is 2. The rank of this matrix is 2. Now I am going to discuss its rank in terms of linearly independent rows. In terms of linearly independent rows. Okay. Right. The rank of this matrix is 2. So the linearly independent rows no ela express chestamo chudandi. So here I am writing alpha 1 equal to 1 comma 2. Anyhow, I wrote it already. So here I am taking one set S1 equal to alpha 1, or you can write directly. You need not have S1 anything notation. You can write directly like this. So set of alpha 1, set of alpha 2, set of alpha 1, alpha 2. Is the first one, is it Li or Ld? Only alpha 1. Is alpha 1 only Li or Ld? This is a non-zero vector. This is a non-zero vector. So even this is also non-zero vector. A single non-zero vector is always Li. So this is a linearly independent set. The same thing happens in case of second one also. This is also a single non-zero vector. So the set is having one linearly independent vector. So set of linearly independent vectors is called Li set. What about alpha 1, alpha 2? మీరు alpha 1 ని ఏ number తో multiply చేసినా alpha 2 రాదు. So I can write either like this or like this. Alpha 2 not equal to k into alpha 1. So therefore even this is also Li set. Is this point clear? So only when you consider alpha 1, it is Li set. Only alpha 2 Li set. Only along with alpha 1, alpha 2, it becomes Li set. Sir, ఇంకేమైనా possibilities ఉన్నాయా? మీరు సెట్స్ లో ఎందుకు రాశారు? Let us see. మీరు 2x2 matrix కి ర్యాంక్ ఫైండ్ అవుట్ చేస్తున్నప్పుడు what I told in the previous classes, first det value find out చేయండి. నాట్ ఈక్వల్ టు 0 వస్తే ర్యాంక్ 2 అవుతుంది. లేదనుకోండి det value 0 అయితే ర్యాంక్ 2 కాదు. ర్యాంక్ 2 కాదంటే 1 కన్ఫర్మ్ చేయొద్దు. If you able to find at least one 1 cross 1 submatrix where determinant is not equal to 0, then you can say that its rank is 1. Sir, అది కూడా వర్కౌట్ అవ్వలేదు. All 1 by 1 submatrices have 0 determinant. Then you can say that rank not equal to 1. So rank not equal to 2, rank not equal to 1. Ultimately, you can say that rank of the matrix is 0. And we know that rank will be 0 only in case of a null matrix. Okay. So ఇప్పుడు మనం ఏం చేస్తున్నాం అంటే 2, 1, 0 అంటున్నాం కదా. ఇక్కడ 1 నుంచి 2 వచ్చాను. So this is one of the linearly independent set having one vector. Linearly independent set having one vector. Linearly independent set having two vectors. So the maximum number of linearly independent rows or the maximum number of linearly the maximum number of elements or the maximum number of vectors in any linearly independent set is called rank of a matrix. The maximum number of linearly independent rows in any linearly independent set, or in simple words, the maximum number of linearly independent rows or independent columns of a matrix is called rank of a matrix. I think the definition is very clear. So I am going to write this. The rank of capital A is defined as maximum number of linearly independent vectors. Here vectors means they can be rows or columns. Maximum number of linearly independent vectors or rows or columns of A. So the rank of any matrix can be square or rectangular. The rank of A is defined as maximum number of linearly independent vectors, rows or columns of A. I think the definition is very clear. Very, very clear. No issues at all. So in this case, this has to be considered. So it contains two vectors. It is Li set. So it contains only one vector, but here I am having two vectors. So what are the maximum number of rows in any linearly independent set? The maximum number of rows or columns in any linearly independent set, 2 only. So therefore the rank of this matrix is 2. I think this point is very clear. Let's have one 3x3 example. You will get more clarification again. Suppose let us take example 2, 3 by 3 matrix. Suppose I have 2, 1, minus 3, 0, 4, 0. Say this is 8, 4, minus 12. So here alpha 1 equal to first row, 2, 1, minus 3. Alpha 2 equal to second row, 0, 4, 0. Alpha 3 equal to 8, 4, minus 12. With the normal experience or with the previous classes experience, what is the rank of this matrix? You can say, the matrix rank chepandi. What is the rank of this matrix? With the previous class experience, in the very starting days, we had a discussion about rank of a matrix. Many examples I had discussed in the class. 3 by 3 matrix kada maximum rank 3 వస్తుంది. But ఇక్కడ చూడండి, second row, last row is 4 times of first one. So ఈ matrix rank 3 కాదు, 2 అయ్యే ఛాన్స్ ఉంది. You will get 2. అవి ఎలాగో చూద్దాం. First I will consider this alpha 1. Next I will consider only alpha 2. Next I will consider alpha 3. Next I will take 2 vectors at a time. Alpha 1, alpha 2. Alpha 1, alpha 3. Alpha 2, alpha 3. Next I will consider alpha 1, alpha 2, alpha 3. Alpha 1, alpha 2, alpha 3. Right. Please observe this example very clearly. Attention please, my dear students. ఈ డెఫినేషన్ కి ప్రీవియస్ డెఫినేషన్ కి కోరిలేషన్ ఏమైనా ఉందా? ఐఎమ్ గోయింగ్ టు ఎక్స్ప్లెయిన్ దట్. 3 by 3 మ్యాట్రిక్స్ కి మాక్సిమం ర్యాంక్ ఎంత వస్తుంది? 3 వస్తుంది. 3. సో ఫస్ట్ మనం 3 కాదా చెక్ చేస్తాం. 3 ఫెయిల్ అయింది అనుకోండి, 2 కాదా వెరిఫై చేస్తాం. ఇఫ్ ఇట్ వర్క్స్ ఓకే. ఇది ఫెయిల్ అయింది అనుకోండి, 1 కాదా చెక్ చేస్తాం. ఇఫ్ ఇట్ వర్క్స్ యు ఆర్ లక్కీ. అదర్వైజ్ యూ కెన్ సే దట్ ర్యాంక్ బికమ్స్ 0. am I right? ఇక్కడ చూడండి, 3 వెక్టర్స్ రాసామంటే ఇది లీనియర్లీ ఇండిపెండెంట్ సెట్ అయితే ఐ కెన్ సే దట్ ఇట్స్ ర్యాంక్ ఈస్ 2. 3. If it is linearly independent set, I can say rank is 3 because it contains 3 rows. Suppose ఇది linearly independent set కాకపోతే ఇంకా 3 అయ్యే ఛాన్స్ లేదు, అప్పుడు 2 కి వస్తాను. So you go in this direction. So here it is 3, here it is 2, here it is 1. Got my point? So this set is LD set, linearly dependent set. How can you say that alpha 1, alpha 2, alpha 3 is this set is linearly dependent set? Please look at this. Here alpha 3 equal to 4 times of alpha 1. So therefore 4 alpha 1 plus 0 into alpha 2 plus minus 1 into alpha 3 equal to 0 bar. So this is A1 and this is A2, this is A3. So linear combination becoming 0, but for there are some non-zero constants. So that's why this is LD set. LD sets are not useful in defining the rank of a set. So 3 elements ఉన్న సెట్ తీసుకున్నాము, అవి LD set వచ్చింది. So this is not at all useful to get the rank of the matrix. Next alpha 1, alpha 2 కి వెళ్దాం. Now you can look at this. This is Li set. Alpha 1, alpha 3. This is LD set. LD set is not useful. Alpha 2, alpha 3. This is Li set. Useful to me. Alpha 1, single non-zero vector. This is Li. This is Li. This is Li. So there are multiple number of linearly independent sets. So in this case, you are having maximum number of rows. In this case, you will have maximum number of rows. Therefore, the rank of this matrix is 2. The rank of this matrix is 2. Is my point clear? So 3 by 3 matrix in rank evaluate చేసేటప్పుడు according to Walden procedure, what I suggested to you or what I advised to you, first verify whether this matrix has rank 3 or not. 3 fail అయితే 2 గా చెక్ చేయండి. 2 వర్కౌట్ అవ్వకపోతే 1 గా చెక్ చేయండి. అయితే ఓకే అవ్వకపోతే లోయర్ డైమెన్షన్స్ కి రండి. ఇక్కడ కూడా అంతే, అక్కడ డైమెన్షన్ అంటున్నాము, ఇక్కడ నంబర్ ఆఫ్ ఎలిమెంట్స్ ఇన్సైడ్ లీనియర్లీ ఇండిపెండెంట్ సెట్ అంటున్నాం. బోత్ ఆర్ సేమ్. సో అందుకని ఇక్కడ మీకు ఏంటంటే సింగిల్ వెక్టర్స్ రాశాను అనేసి అంటే అవి లీనియర్లీ ఇండిపెండెంట్ డిపెండెంట్ చూస్తున్నా. టూ వెక్టర్స్ ఒకే సెట్ లో రాశాను అని అంటే ఐఎమ్ వెరిఫైయింగ్ దట్ వెదర్ ఆర్ ఎల్ఐ ఆర్ ఎల్డి. ఎల్డి సెట్స్ ఆర్ నాట్ యూస్ఫుల్ ఫర్ మీ. ఇక్కడ ఎల్డి సెట్స్ ర్యాంక్ ఎలాగైతే యూస్ కావో, in case of previous definition, the submatrices where determinant is going to be 0, those dimensions are not at all useful to me. The same case here, LD is nothing but their determinant is 0. Here Li is nothing but their determinant is not equal to 0. I think the definition is very clear, my dear students. No doubts at all. Clear? No confusion. All the points are very clear. So therefore అందుకని మీకు ఫస్ట్ సింగిల్ రాశాను, టూ రాశాను, 3 రాశాను. సో I explained from down level to bottom level. Okay. Down to up level. So alpha 1, alpha 2, alpha 3 అది linearly dependent set. Why? Because of this reason. Linearly dependent. So linearly dependent set వచ్చింది, 3 vectors ఉన్నాయి. So rank not equal to 3. So because of this I can say that rank not equal to 3. 2 కాదు చెక్ చేద్దాం. So if I able to find at least 1 2x2 submatrix of A where that is not equal to 0, according to old definition it is 2. So in this case, if I able to find at least one linearly independent set having 2 elements, I can say that rank is 2. Understand my points? Very, very clear. No doubts at all. So therefore, the maximum number of rows in any linearly independent set in this case is 2. So here I am writing the maximum number of linearly independent rows in any Li set is 2. So that's why the rank of this matrix is 2. The rank of this matrix is 2. I will tell you once more. Final point. Attention please. Still ఇంకా ఎవరికైనా కన్ఫ్యూజన్ ఉంటే ఈ పాయింట్ చాలా కేర్ఫుల్ గా వినండి. వెరీ వెరీ కేర్ఫుల్. ఓ 3x3 మ్యాట్రిక్స్ కి ర్యాంక్ ఫైండ్ అవుట్ చేయాలంటే ఎలా చేయాలి అకార్డింగ్ టు అవర్ ఓల్డ్ ఎక్స్పీరియన్స్. అసలు 3x3 మ్యాట్రిక్స్ కి పాసిబుల్ ర్యాంక్స్ ఏముంటాయి? 3 or 2 or 1 or it can be 0. సో ఎలా ఫైండ్ అవుట్ చేయాలి? ఫస్ట్ డిటర్మినెంట్ ఫైండ్ అవుట్ చేయండి. If the determinant of 3x3 matrix is not equal to 0, it means that rank is 3. అంటే దాని అర్థం ఏంటో తెలుసా? ఆ 3 rows linearly independent అని అర్థం. Or those 3 columns are linearly independent. లేదు సార్, ఆ 3x3 matrix కి determinant 0 వచ్చింది అంటే rank 3 కాదు. It means that few rows or few columns of that matrix are LD. That's why when you combine all the rows or all the columns, you are getting LD. Next time చేయాలి 2x2 కి వెళ్ళాలి. So if you find any 2x2 submatrix of A with a non-zero date, I can say that rank is 2. ఇక్కడ నేను ఏం చేస్తున్నాను? If you able to find any linearly independent set, at least one linearly independent set with having 2 rows or 2 columns, I can say that rank is 2. Suppose if I don't find any linearly independent set with 2 vectors, so I can say that rank not equal to 2. Then I need to go for linearly independent sets with 1 vector. If it works, 1. Otherwise, I can say 0. So you compare linearly dependent with determinant 0. You compare linearly independent with non-zero determinant. Hope this point. Now here you can see the first row and last row are linearly dependent. So even if you take this matrix, suppose 0 0 0, 1 2 1, 3 6 2, 3 6 2. So the last 2 rows linearly independent. ఇది linearly dependent single 0. ఒక్క linearly dependent row ఉన్నా, ఒక్క linearly dependent column ఉన్నా det value 0 వస్తుంది. The same thing. It means that if any square matrix contains at least one linearly dependent row or linearly dependent column, the determinant of a matrix is 0. Point is clear. So here my note is if a square matrix A contains at least one linearly dependent row, dependent, D stands for dependent, or column, then det A is 0. Then det A is 0. This point is clear, right? Now I'm going to discuss few more points. I want to establish a relation between rank of A and rank of A transpose. Do you say both are equal? Rank of A and rank of A transpose? Simple logic and what is the definition of rank of A? The maximum number of linearly independent rows or the maximum number of linearly independent columns. Row na column na vector antam. Sometimes I may use row, sometimes I may use column, sometimes I may use vector. Don't worry, everything is same. So the maximum number of linearly independent rows of a matrix is called its rank. A matrix is transpose cheyandi. So rows become columns. So it means that the rank of A will be always same as rank of A transpose. And moreover, I can have this relation also. So rank of A equal to rank of A transpose. This is same as rank of A into A transpose. This is also same as rank of A transpose into A. This is clear. The point is clear. Right. Next, I want to discuss one more point. We know that the trace of A is nothing but the trace of A transpose. You can call it as equation 1. Det A equal to det of A transpose. You can call it as equation 2. From this, can you say that eigenvalues of A and eigenvalues of A transpose are same? Trace of A transpose same. Determinant of A transpose same. Do you say that eigenvalues of A and A transpose same? Definitely. Assume that eigenvalues of A are lambda 1 comma lambda 2. Assume that eigenvalues of A transpose are alpha comma beta. So equation 1 implies trace of A means sum of eigenvalues. Lambda 1 plus lambda 2. Trace of A transpose means sum of eigenvalues of A transpose. That is alpha plus beta. From equation 2 implies determinant of A means product of eigenvalues of A. You get lambda 1 into lambda 2. Det of A transpose means product of eigenvalues of A transpose. But eigenvalues of A transpose are alpha and beta. So you will get beta. So alpha 1 plus alpha 2 equal to alpha plus beta. Lambda 1 into lambda 2 equal to alpha into beta. So when you combine these two, you can say that both are same. So therefore, eigenvalues of A comma A transpose are same. Eigenvalues of A comma A transpose are same. Very, very clear. Right. Now I would like to know how eigenvalues of an orthogonal matrix look like. A into A transpose equal to A transpose into A equal to I. It means that the matrix is orthogonal. So it means that A inverse equal to A transpose. A inverse equal to A transpose. Got it? So here I am going to apply spectral theorem. Suppose if lambda is an eigenvalue of A. So it means that lambda inverse becomes an eigenvalue of A. Even eigenvalues of A and A transpose are same. Lambda inverse means 1 by lambda. So this implies lambda square equal to 1. So therefore lambda equal to plus or minus 1. So it means that eigenvalues of any orthogonal matrix will be either plus or minus 1. And even I can say that its modulus absolute value will be always 1. So therefore the conclusion is not the absolute value of eigenvalues of an orthogonal matrix is 1. I think this point is clear. This point is very, very clear. So let us take an orthogonal matrix A into A transpose is equal to I. This is similar to A dot B equal to B dot A equal to I. Definition of invertible matrix. So when you combine these two, you will get A inverse equal to B. It means that A inverse equal to A transpose. I wrote here. Suppose here lambda is an eigenvalue of A. Then according to spectral theorem, matrix should be replaced by its eigenvalue. So A and A transpose will have same eigenvalues. So lambda inverse equal to n. You simplify, you will get lambda square equal to 1. So lambda becomes plus or minus 1. It means that eigenvalues of any orthogonal matrix is either plus 1 or minus 1. So when you take its absolute value, you will get 1. So the conclusion is the absolute value of eigenvalues of an orthogonal matrix is always 1. I think hope this point is very, very clear. Wait for a few minutes. This is official Creatrix channel where you can find 10,000 members. And this is our Telegram channel where you can find links of our live classes. And once after completion of class, we are sharing notes in PDF format. I think everybody is getting this. Okay. These are India's #1 studies channels running by Unacademy. That's why we always say Unacademy is the best online platform in India for all competitive examinations. You can see there is a channel for Telugu, electrical junction, for civil, mechanical sciences, electrical sciences, like this. SSC, JE, junior engineers, computer science. For all branches, multiple channels are there. Right. Thank you guys. Thank you so much for bearing me since last 1 hour 15 minutes. I hope we had an extraordinary session. Tomorrow also we are going to have norm of an eigenvector, normalized eigenvector, number of scalar multiplications required to multiply few number of matrices, n number of matrices, and then we discuss complex matrices, Hermitian, skew Hermitian, unitary matrices. And if time permits, we solve some interesting questions also. Okay. Thanks a lot. Thank you guys. Thank you so much. We meet again after half an hour.